is angles of elevation and depression. Yeah.
What was this?
Your notes. Oh, you gave me, did you come? So, very back page, very short lesson. There's not a lot here.
It's just this?
It's just that. Okay? And then we're just going to try some of our basic stuff again. Here's the deal with today's lesson. We are talking about angles of elevation and angles of depression. Do I need to close it? Can we do this today?
There's this guy that's late
And yet you still find it interesting.
Why is he late?
6 months later. This is working from eye level. Okay? This is probably the most important aspect of what you're going to do right now, is you have to come from eye level. Okay? There are what are called angles of elevation and angles of depression. And if you think about when you think about an elevator, what do you think about? Where's it taking you? It's taking you up, right? Yes, it takes you down, but I feel like when people think about getting on an elevator, you're on like ground level and you're going up, right? So elevation, like if you elevate your eyes, you look up, right? That's an angle of elevation. If you look down, right? If you're feeling down in life, if you are sad, there is depression, right? So looking down is an angle of depression. Another way to think about where you're starting, that eye level, is the horizon. Like if you look out on the horizon, right, you're looking at the level of the land out ahead of you. So horizon, eye level, you'll hear me say both of them. But that's where we want to be starting from. Okay, so now we're going to talk which ones are angles of elevation and which ones are angles of depression and how are they related to each other. So let's say you are flying in an airplane. Okay, this is your eye level right now. Okay, if that's your eye level, angle 1, in order for you to look at the air traffic controller, you had to look down. Is that an angle of elevation or depression? That is an angle of depression. Okay, let's say you are the air traffic controller and you look to the airplane. Is that an angle of elevation or depression?
Elevation.
That is elevation. So here's your horizontal. This one is elevation. Can anyone tell me something about angle 1 and angle 2? What do you know about angle 1 and angle 2?
They're equal.
They're equal. Do you know what kind of angles those are?
Parallel.
There are parallel lines, which make those alternate interior angles, right? So those are the same angle measure, but one is an angle of elevation and one is an angle of depression.
Are we going to be
Okay.
tested on this too?
Yeah, like I'll draw the picture for you of what you're going to have to do with it. It's SOHCAHTOA. You'll see. We're going to just do more SOHCAHTOA with it. Okay, so now look here. You are the air traffic controller and looking at the ground crew. Okay, so here's your line of sight as the air traffic controller. You are looking at the ground crew. Is that an angle of elevation or depression? Depression. You have to look down to the ground crew. Okay, so then if you are the ground crew and you look at the air traffic controller, is that elevation or depression?
Elevation.
That's elevation. You're looking up. Okay, so those are the different types of angles you're going to see. The first several questions on your homework are just telling me, is it an angle of depression, angle of elevation, what kind of angle is it? Okay. The rest of it is word problems. Yes. Okay, so here's what it says. John stands 120 feet from the base of a tree. Okay, I'm here.
This woman's so confused.
Who cares? Oh my gosh, you guys are... Okay, so here it is. This says John stands 120 feet from the base of a tree. Okay, so you have a tree. That was a terrible tree. Here's your tree.
Wait, is the tree 120 feet tall then?
No.
Or is he
Wait, so it's a redwood, right?
Sure.
Cool.
It says he stands 120 feet. Okay, so here's John.
He's at the bottom?
Is he 120 feet away
Elevation.
He's 120 feet away from the tree.
Wait, where am I?
Okay?
Oh, right here.
Draw that picture. It says the angle of elevation, just one elevation, I don't know why there's an S there, from eye level to the top of the tree is 40 degrees. Okay, so think about where is John's eye level. If he's looking straight out right
It's
now,
right where his head is.
here's John's eye level.
120 minus 5?
Okay? No,
Oh.
we'll get there. His angle of elevation to the top of the tree. So from eye level, he's looking where if it's an angle of elevation? Up, right? He's elevating his eyes. So if he looks up to the top of the tree, up here, it's saying that is a 40-degree angle. Okay? Angle of elevation. Now, it says that John is 5 feet tall at eye level. Okay? John's height up to his eye level is 5 feet. So this height right here,
He's 5 feet tall.
well, his eye level is 5 feet,
But that's like.
right? So he's probably 5'3".
What if his forehead was like 6 feet?
That would be a really big forehead.
Disproportionate.
Here's the question. They want to know, what is the height of the tree? Okay, so here's your picture. We're trying to solve
This doesn't make any sense.
for this. Okay?
Wait, we're still using Sokotoa.
Would it be
We are
150
using
feet?
Sokotoa. So here's the deal.
Wouldn't it just be 150 feet?
Your triangle, okay, this line right here, that extra line, that's 120, okay? Because that's how far he is from the base of the tree. This angle, because the tree stands straight up, is a right angle. We're looking for this length. I know this piece of it is how much?
5 feet.
5 feet,
So it would be
right? That's his
150
height.
Feet?
No. Okay, so I know this is 5. Can we find this?
No.
Stop and look at the picture.
Wouldn't it be
Just stop and
150?
look at the picture.
I am looking. I'm subtracting 100.
Do you see the right triangle?
Oh, we don't even know how. I was assuming it was 120 feet tall.
Wait, we don't know how tall
So is this where we use Sokotoa?
Mm-hmm.
How?
How would you use Sokotoa? Where do you always start in Sokotoa?
Give an angle.
The angle.
At the 40, at the angle,
So you have
okay?
adjacent,
This is your adjacent.
opposite.
You're solving for the opposite,
Tan.
right? That's tangent. Good work, team. So we're saying the tangent of what? What always comes after trig?
Tan 40 equals x over
X,
120.
X over 120.
Over 120, right?
Yes.
Opposite over adjacent. Well played, Truett. Okay, so this is your setup to solve for x, but x is not our answer. Keep that in mind. How do we solve for x right now, though?
Multiply 120 on both sides.
Multiply by 120. So you're going to plug this into your calculator. Plug in 120 tan 40. Okay, so if this is x right now is 100.7, we'll say, if we round to the nearest tenth. I want to know how tall is the tree, the whole tree. So I want to know,
Wouldn't you just add 5?
Oh,
yes,
five.
you add 5 to it. So we found x. We take that 100.7 and we add 5 to it. So it's 105.7 feet. Does that make sense? So you got to set up the Sokotoa and then add that extra little bit to it.
I just don't understand. Can you show me how to enter the calculator?
Yeah.
Because when you go to multiply it, that's the part where I get lost because I don't know how to put it in.
So see, it's 120 tan 40.
Mm-hmm.
So you literally just hit 120 tan 40.
Oh, okay. Thank you.
You're welcome. Okay. This next one is a little harder to set up. whenever it's an angle of depression, it's trickier because the angle of depression, people always forget that you have to start from eye level. Okay, so just keep in mind that you're always starting from a horizontal line and then going down from there to make your angle. Okay, so let's see if we can draw a picture of this. It says a rescue worker is located 175 feet above the ground in a lighthouse. So I don't care what your lighthouse looks like. Mine's going to look like this.
That's a good lighthouse.
Thank you.
Might be on top of it.
Okay, so this height of the lighthouse is 175 feet. Oops. Okay, rescue worker is 175 feet above the ground in a lighthouse. It says he spots a ship on the water. So we're in the water here. Okay. He sees a ship.
Wait, we're in the water?
Well, the ship is in the water.
This isn't real nice.
My ship is just going to be a sailboat because that's as good as it gets for me. Okay, so there's a boat. It says he sees that boat in the water. So he's here, he's looking down at the boat. Okay. And it says, oh, I didn't draw that to scale. Shucks. It says at an angle of depression of 62 degrees. What is an angle of depression, first of all? Looking down, okay? So we have to think about where is this rescue worker's eye level? If he's up here in the lighthouse, his eye level is here,
Oh.
right? So where is my angle of depression? Where is he looking down to?
The boat. The boat.
He's looking down to the boat. Is that this angle or this angle?
That angle.
The two arc or the single arc?
Single.
It's the
Double.
double.
It's the double. You
Because
always
opposite
come from the
side
horizontal
here.
line, right?
Yeah.
So
but
that
he's
means
looking down.
this angle, right? He was here. His eyesight is here. He looks down. So that's this angle. Okay? So now you have options. The question is, how far from the base of the lighthouse is the ship? So here's the base. Here's the boat. We want to know what is this length. Okay, that's what we're trying to solve for. You can either use that 62 as a 62, or you can find another angle in the triangle and use that other angle instead. I don't care which one you do. It's about what you see. Does anyone think they know either this angle here or this angle here?
Well, isn't the angle at the bottom 62?
Right, why?
Because it's equal to the one up there.
Right, they're alternate interiors. Okay, so one option is because I know this one is 62, I know this one is 62 also. Right, those are alternate interior angles. Okay, so you could do that. Does anyone see it a different way? Anyone see a different way to find the one up top?
Subtract 90 and 62 from 180.
You know it's a right angle, right? If the one is vertical and the other is horizontal, this is 90 degrees. So if you want to use that top one instead, then you would just do 90 minus 62. Right? So that would be a 28-degree angle, which is so not drawn to scale, I'm sorry. Does that make sense, though, how you're doing that?
Yes.
So you get to choose. I don't care which one you do. In a problem like this, I feel like the 28 is easier because then your opposite is the x and your adjacent is here. So your x is on top, and that's one less step in solving it. But I feel like most people tend to see it with the 62. How many of you think you would use the 62?
I don't think I can use either one.
Well, you have to use one of them. Who thinks they would use the 28?
I think I would use the 90.
You can't use the 90. Oh, well, you mean you'd use the 90 to find the other angle? To
Sure.
find this one?
Yeah, I think so.
Okay. Well, so here's the deal. Let's do, let's see what the setup would be from here. If we're at 62, what is the 175 called? Opposite, adjacent, or hypotenuse?
Opposite.
That's your opposite.
What?
Okay. What's the x?
Adjacent.
Oh,
Okay, so if you're using the 62, opposite is the 175, adjacent is the x. If you're using the 28, opposite is x, adjacent is 175. It's totally up to you which one you want to do. So if we're going to use the 62 right now, opposite and adjacent is which trig function?
TOA.
It's the TOA, so that's tangent, right? So we're going to say the tangent of what always comes after that? The angle. Okay, so the tangent of 62 equals opposite over adjacent. How do you solve for x?
Multiply by x and then divide.
Multiply by x. Yes, so multiply by x, multiply by x, this is gone. So you have x times the tangent of 62 equals 175. And now you're going to divide by the tangent of 62 on both sides.
90.
This is what we did like on the test, right?
This was your quiz, yeah. That's why it's not really a new concept, it's just setting it up that's new, setting up the problem. Are you good, Truett? You said what? Okay, rewind. It's a lot of writing that. Oh. It took it all away. Super duper. Stop.
Not as bad though.
Oh, snap.
I did not do that many taps.
Wait, so if we use the SOGA-TOA, do we have to do the, like how you got 28? Like we don't have to do any of that?
You don't have to use the 28 if you're going to use the 62. Okay.
But if we use the.
Do you understand how I got here?
I'll figure it out.
Well, I'm going to talk you through it right now. Do you understand how I got tan 62 equals 175 over x?
Yeah.
Okay. Your next step is you have to get x out of the denominator. And the way you do that is you multiply by the x.
How do you multiply something by x?
Well, it's like saying right now, this x is, we're dividing by x. So we're just trying to do the inverse operation to make it 1,
We
right?
just defined what
X
is, right?
x divided by x is 1. So that's our goal, is get the x out of the right side. And the way we do that is we multiply by x to make it 1, right? X times x. It's like saying if x is 7, 1/7 times 7 is 1, right? Because this is divided by x. This is a denominator. So it's like saying 1/2. If I want to get rid of that 2, I multiply by 2 because 1/2 times 2 is 1. Does that make sense?
Yeah.
So it's just an inverse operation. You're multiplying by what you were dividing by, right? We're dividing by x, so now we need to multiply by x to get it out of there,
Max has a question.
okay? So multiply by x, and now you have this. X tan 62 equals 175. I got it. I'm good. I know. I'm aware.
Well,
Thank
just
you.
started looking, so I didn't know.
I have peripheral vision. It's actually really good. I can see all the way here right now.
I didn't want him to be slow.
Truett, are you with me on that?
Yes.
Okay. So then your last step is divide by tan 62 and divide by tan 62. This is 1, right? Tan 62 divided by tan 62. This is what you would plug into your calculator. 175 divided by tan 62. Max.
I don't understand any of this.
Well, let's do another one.
Why are we trying to find
Just
that?
remove it. Can I go to the back?
Why are we trying to find what?
Why are we trying to find
Because
that?
that's the problem, Max.
Because we're trying to find how far the ship is from the lighthouse.
Wait, Mr. Rubin.
But it equals 62, right?
No. The angle is 62. We're trying to find the distance, right? Okay, here, I'm going to give you another question that doesn't have the whole set up the problem. Yes, quickly. Leave your phone, please.
I really need it.
Okay. Let's set this one up. Max, where do you start on these problems? always? The angle or a side?
Angle?
Always start at the angle. So our angle right now is the 51, right? So then you have to ask yourself, okay, which sides do I have? Cadence. What would we call this side? Opposite, adjacent, or hypotenuse?
The opposite.
That's your opposite. Xavier, what do we call this one? The hypotenuse. Okay, so then you think of our word, SOHCAHTOA. Okay, if you have opposite and hypotenuse is the sine. Okay, so we're going to say the sine. Dakota, what always comes after that trig function? The angle. So it's the sine of 51 equals, and now you do what over what, Luke?
X over 10.
X over 10. It's your opposite over your hypotenuse. Okay, so we're here. Sine 51 equals x over 10. Truett, do you know what your next step is?
Yeah.
What do?
You have to multiply it by x.
That's if x is in the
10.
denominator.
10.
Multiply by 10, right? We're trying to get x by itself. So if x is a numerator, then we don't have to do anything with the x. It's just when it's a denominator, the top number.
Okay.
So this is gone. This is what you plug into your calculator. So plug in 10 sine 51, and you get 7.8. Does that make sense?
Yeah.
Okay.